Hey everyone, and welcome to this explainer. Today we're taking a really fun, deep dive into the absolute building blocks of everyday technology. We're going to break down the massive, sometimes complicated world of information and communication technology into clear, bite-sized concepts. By the end of this, I promise you're going to look at the devices you use every single day in a completely different light.
Okay, so here's our game plan for today. First, we'll define what ICT actually is. Second, we're going to peek inside a computer system. Third, we'll travel through the 5 generations of computers. Fourth, we'll check out ICT in the real world. And finally, we'll weigh the pros and cons. Simple enough, right? Let's get to it.
Section 1. What is ICT?
So, you hear this acronym literally everywhere, right? In the news, at work, in the classroom. But what does this giant umbrella term actually mean? Well, information and communication technology, or ICT, is basically a set of computing tools that together let people and organizations interact in the digital world. It's essentially this brilliant mashup of telephone networks and computer networks all linked into one system. Think of it like a massive umbrella. Underneath this umbrella, you've got everything from the satellites orbiting our planet right down to the cell phone in your pocket. It includes TV broadcasts, network hardware, and everyday services like video conferencing or online classes. It really covers the whole shebang.
Now, to truly understand how all these ICT tools work, we have to look at the fuel they run on. On one side, we have data. This is just a raw collection of facts and figures. On its own, it really doesn't tell us much. It's kind of like scattered puzzle pieces. But on the other side, we have information, which is the processed, organized, and meaningful form of that data. That's the completed puzzle. And honestly, a computer system's #1 job is just taking that raw, unstructured stuff and transforming it into useful, actionable information.
Moving right along to Section 2, inside a computer system.
So how exactly do these devices actually process all that data? Well, it boils down to 2 entirely mutually dependent forces. I like to use a brain and body analogy here. Hardware is the physical body. It represents all those tangible components you can actually see and touch. Your monitor, your keyboard, the mouse. Software, on the other hand, is the invisible mind. It's the set of instructions, data, or programs that literally tell the physical hardware what to do. The catch here is that one absolutely cannot produce useful results without the other. They are a package deal. Now, the crucial point to remember is that while software acts as the mind, the hardware actually has its own physical brain. That's the CPU, or Central Processing Unit. The CPU lives safely tucked away inside the system unit, which is that main physical case that temporarily holds data and instructions. The CPU is the absolute core of the physical hardware, processing every single command that the software throws its way. Let's quickly unpack that invisible set of instructions we call software, because it's not just one big thing. It actually comes in 3 distinct flavors. First up, system software. This is the main interface between the hardware and the apps you use. It runs the hardware. Think Windows, macOS, or Android. Second, we have application software. These are the programs that perform specific tasks for you. Almost all the apps sitting on your smartphone right now, your web browser, your games, your word processors, yep, those are all application software. And finally, we have driver software. These control very specific connected devices. So when you plug in a new printer or a scanner, driver software is what tells your computer exactly how to talk to it. Let's shift gears to Section 3, the 5 computer generations. We are so used to having incredibly advanced tech at our fingertips today, but it definitely didn't happen overnight. For literally thousands of years, humans used manual devices like the abacus. It wasn't until Charles Babbage designed the analytical engine in 1833 that things really started rolling. Since then, we've seen 5 major computer generations. And as we go through these, notice how the physical machines keep shrinking while their processing power absolutely explodes. The first generation kicked off around 1940 using vacuum tubes. These things were massive, incredibly expensive, and generated so much heat. By 1957, the second generation arrived, ditching vacuum tubes for transistors, which were way smaller, faster, and more efficient. Then, the third gen brought us integrated circuits in the mid-60s, meaning a single tiny chip could do the work of many transistors. Prices dropped, and reliability went way up. The fourth generation, heading into the 1980s, introduced microprocessors and programming languages like C++ and Java. And finally, the fifth generation, the era we're living in right now, is completely defined by the rapid rise of artificial intelligence. That brings us to Section 4, ICT in the real world. ICT is not just a bunch of tools anymore, it is completely integrated into our lifestyle.
let's look at how it actually measures and interacts with our world. Because these systems are so incredibly good at reading sensor data, they are vital for real-world stuff. We're talking about running highly precise digital experiments using scientific data logging. We're talking environmental monitoring, where computers collect vast amounts of data to forecast the weather or track pollution levels. And of course, navigation. Whether you are tracking a car on a highway, a cargo ship at sea, an airplane, or even a spacecraft, ICT processes that sensor data to safely guide vehicles from point A to point B. And this brilliantly illustrates how ICT has totally revolutionized the manufacturing industry too. Bringing these networks and computers into factories led to automated, heavy-duty machines that drastically increase productivity and save tons of time. Just think about highly precise robots welding and painting car parts on an assembly line, or the unbelievably delicate process of making microchips. Then there's 3D printing. Even just automated systems packing boxes and safely lifting massive heavy objects so human workers don't risk injury. It's a real game changer.
But beyond the factory floor, ICT is literally the backbone of the modern business world. It makes companies so much more efficient. By tracking sales and customer feedback through computer networks, businesses can make vastly better decisions. ICT systems reduce manual labor costs, seriously boost overall productivity, streamline customer service, and allow for hyper-precise tracking of finances. It's basically what keeps businesses competitive today.
And finally, Section 5, Pros and Cons of ICT.
Look, all this incredible technology is for sure a double-edged sword. It brings immense, world-changing benefits to the table, but it also carries some very real risks that we have to keep in check. On the plus side, ICT is highly eco-friendly because it pushes us toward paperless environments. It automates boring, tedious, manual tasks. It beautifully bridges cultural divides by letting us communicate instantly across the globe. And it massively enhances education through digital, web-based learning. But we have to look at the flip side. We are constantly facing the severe risk of cyber attacks. The internet makes spreading misleading or false information almost effortless. Plus, setting up these massive networks is highly expensive and requires specialized experts. There's even a genuine risk of losing our traditional skills, like physical book reading and handwriting, just because we are so totally reliant on screens and keyboards. So we know we are currently living in the 5th generation of computers, an era totally defined by artificial intelligence. Now, if the jump from those massive, heat-generating vacuum tubes to tiny microprocessors changed our world this drastically, how on earth is AI going to profoundly shape the next era of ICT in our daily lives? Will it amplify all those incredible advantages we just talked about, or will it make the disadvantages even worse? That is exactly the frontier we are stepping into right now. Thank you so much for hanging out with me for this explainer. Keep asking those big questions, keep learning, and I will catch you next time.